Good morning, good afternoon, or good evening, folks, and welcome back to Unit 8. Today we are covering Lesson 8.3, which is called Types of Forces. This will be a pretty quick unit, so let's go ahead and jump right into it. Let's start by discussing gravity. Gravity is an attractive force that exists between any two objects that have mass and energy. So for example, when you see an apple falling to the ground, the apple is falling because of the gravitational attraction between the apple and the planet Earth. Now remember, all forces operate in equal and opposite directions. So just as the apple is attracted down to Earth, Earth is also attracted upwards towards the apple. But Earth barely moves because it's so massive, whereas the apple has a much smaller mass and therefore accelerates more quickly. All objects that have mass experience a gravitational attraction between them. But the amount of attraction depends on two factors. First of all, the masses of the objects, and also how far apart the objects are. The more massive the objects are, the stronger the gravitational attraction will be between them, and the closer together they are, the stronger they're attracted. Now here we see a happy couple, and they're very close together, so their gravitational attraction is just about as strong as it can get. However, even when they're real close together, the gravitational attraction of these two people for each other is absolutely tiny compared to the attraction between either person and the Earth, because Earth, of course, is much more massive than either of these two people. So they do experience a tiny gravitational attraction, but they wouldn't really feel or notice that attraction as long as they're so close to Earth. So here are some charts to show the relationships between the masses of two objects that are attracting each other and their distance. If you increase the mass of either object, then the gravitational force increases. So it doesn't matter if one object has a very small mass. If the other object's mass is very large, then the gravitational force between them will be very large. That's why small objects like, say, people, have a strong gravitational attraction to the Earth. It's not that the people are very massive, but Earth is. This graph shows what happens to the gravitational attraction between two objects as you increase the distance. The farther apart two objects are, the weaker the gravitational force is between them. And gravitational force has what we call an inverse square relationship with distance, which means that if you double the distance between two objects, the gravitational force between them doesn't decrease by 2, it decreases by 4. So if you double the distance, then the gravitational force is 1/4 as strong. And if you triple the distance between two objects, then the gravitational force between them is 1/9 as strong. Whatever you do to the distance, the inverse square of that is what happens to the gravitational force. One factor that we're going to see in units that we're coming up to is the acceleration due to gravity. On Earth's surface, all objects accelerate towards the ground at 9.81 meters per second squared, if we ignore air resistance. Now, air resistance can cause this acceleration to be less, but if we pretend that air is not a factor, then all objects near Earth's surface accelerate downward at 9.81 meters per second squared. And you might think that a heavier object would accelerate faster, and it is pulled down by more force, but it also has more inertia, so it has more resistance to acceleration. And those two factors cancel each other out. So all objects near Earth's surface, if you take away air resistance, will accelerate at the same rate. The moon has less mass, so the acceleration due to gravity on the moon's surface is only 1.63 meters per second squared. So if we drop the same object from the same height, but one on the surface of Earth and one on the surface of the moon, the object on Earth will accelerate much more quickly and will hit the ground sooner than the object dropped from the same height on the moon's surface. Weight is simply the acceleration due to gravity. Or it's the force caused by the acceleration due to gravity, I should say. If you remember Newton's second law says that force is equal to mass times acceleration. Well, weight is a type of force, and it's specifically the force associated with the acceleration due to gravity. We abbreviate weight with an FW, the F to show that it is a force, and the W to indicate what type of force it is. The weight of an object is equal to its mass multiplied by the acceleration due to gravity. Now keep in mind that weight and mass are not the same thing. If you go to the moon, for example, your mass will stay the same, but the gravity pulling down on you will change, so your weight will change. So let's do a word problem. A textbook has a mass of 3 kilograms. What is its weight in newtons on Earth, where g is equal to 9.81 meters per second squared? This is a pretty simple problem, but we'll use the guess method to solve it. The given information is that the mass of the textbook is 3 kilograms, so we'll put m equals 3 kilograms, and the acceleration due to gravity on Earth is 9.81 meters per second squared. The unknown information is the weight. Weight is equal to what? We will use the equation for weight. Weight is equal to mass times gravity. And then we will plug in 3 kilograms for mass and 9.81 meters per second squared for gravity. And now all we have to do is multiply those two numbers together, and we'll get 29.43. And for the unit, we get kilograms times meters per second squared, which is equal to a newton. Want to check to see if this answer makes sense? Yes, we were trying to solve for a force, specifically weight. So the answer should have units of force, which in this case is newtons, and that works. One other force that we want to talk about is friction. And friction is a force that opposes relative motion. In other words, it opposes two objects from moving with respect to each other. If an object is at rest, if an object is at rest, then friction is what keeps the object from starting to slide. If you want to push the object and cause it to start sliding, you have to overcome the friction that is holding the object in place. If an object is moving, friction is what causes the object to slow down and stop moving. If there were no friction and you pushed an object, it would just keep moving forever and it would never, ever, ever slow down. But there is friction, and that is a force, and as soon as you stop pushing the object, then friction becomes the unbalanced force that causes the object to have negative acceleration. So if we start with a box sliding across the tabletop, friction is the force that will eventually bring that box to a stop, unless we continue to push the box to counteract the friction. There are 4 major types of friction. The first is static friction. Static means stationary or not moving. So this is the friction that you have to overcome if you want to make an object start sliding across the floor. If you want to push a heavy object like a sofa or a refrigerator, you have to apply enough force to break this static friction before the object will start to slide. Once it does start to slide, then the friction changes to what we call kinetic or sliding friction. Kinetic is a word that means moving, and we'll talk about this word in much greater detail in our next chapter. Kinetic friction will cause an object to slow down and stop unless you continue to push on that object to counteract the kinetic friction and keep it moving. Rolling friction is exactly what it sounds like. It's the friction associated with wheels and ball bearings. And fluid friction, also known as drag, is the friction of an object that is moving through a fluid. And when we say a fluid, that could be either water or air. Fluid just means something that flows. So water and air are fluids, and anything that moves through the water or through the air experiences drag because it has to push the water or push the air out of the way in order to go through it, and that requires a force. So that's going to be the end of lesson 8.3. Thank you so much for tuning in, folks. I appreciate it. I hope you are continuing to stay well. Keep washing your hands. Check back in tomorrow when we'll be starting on Unit 9, which is all about energy, work, power, and machines. Talk to you then. Take care. Bye.